So next up in our series of videos on modeling, we are going to look at the different graphs that these different equations, same list of equations, make. And we're going to learn how you can take a list of points like this and figure out what kind of graph will make that equation. Okay? So we're going to just talk about what these different graph shapes look like. So we'll just draw a picture for each of these here. When something is constant, it never changes. So if you have a constant equation, what you will see as far as the graph is a horizontal line. Always did the same. So if you graph your points and, ooh, they make a horizontal line, that's a constant equation. Linear equations, you guys already know. Linear is a line, but not a horizontal one, so it can either be a increasing or decreasing in nature. But if you graph your points and they look like this, we're looking at a linear situation. Quadratic, of course, is our parabolas. So we can have a parabola opening up or down. Those would be quadratic. Cubic equations tend to have, they go in different directions like this, they tend to have two bumps on them like that. So you might see an equation like this or like this. Those would be examples of cubic equations. Exponentials are going to be our L or our J-shaped graphs. So we have a graph going upwards like this, that would be exponential growth. Or we could have exponential decay, remembering that they have a horizontal asymptote. So they tail off horizontally for exponentials. Logs are like an inverse of that, a flipped version. They're going to have the vertical asymptote. They have a not steep side, they have the asymptote going downwards. So that's what a log graph is going to look like. Absolute value graphs are the V's. So they are straight on both sides. And finally, periodic, like I showed in that last video, those kind of make waves as they go along. So they repeat the same pattern. They just go in waves over and over like that. So that would be a periodic graph. So if they hand you a set of points and they say, what kind of equation makes this graph with those points right there? Your best course of action in a problem like that is just plot the points and look at what shape the graph makes. So I'm just going to take the 5 points I have right here and plot them and see what that does for me. So I have -5, 1, I have -3, 5, I have -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 5, and I have 3, 1. So you can kind of do process of elimination here. My points are going up and they come back down. That could potentially be absolute value, or it could be quadratic. We just have to decide if it's straight or if it's curved. And if you look, the rise over run on these points is the same. This makes a V, not a parabola. It's very straight to connect these points right here. You can draw a straight line through them. That means that these points are modeled by an absolute value equation. So if you see a set of points, best option probably, graph those points, and then just look at the graph and see what kind of equation it would make using this chart right here.